change in the fundraising sector has never been greater. But innovations in technology are evolving faster than our ability to understand them. Are these advances good or bad? Do they have unintended consequences? And what is the application to the global fundraising sector? That's what we're here to find out. Welcome to the Fundraising AI podcast, your up-to-date resource for responsible AI for the global fundraising community, hosted by Nathan Chappell and Scott Rosenkrantz.
Hey everyone, welcome back for another episode of the Fundraising AI podcast. I'm Nathan Chappell. I am here on a Friday afternoon with Dan Basco. Your thing says Dan here, but I've always known you as Daniel. So I don't know. What do people call you? What do family call you or your friends call you?
Yeah, it's both Dan and Daniel. I actually didn't have a first name until college because my last name's Basco and I have older brothers. So every coach, every teacher, every friend would just call all of us Basco.
Okay. And so sorry, I didn't even realize it was Basco because it's an A, and I have a dog named Basco named after the chocolate syrup. So are you any relation, and are you the heir of Basco chocolate syrup?
Gosh, I wish I was. No, actually. Family, I'm Mexican by descent. When my family crossed the border, decided a new last name, and somehow Basco is what got written down. And so that's what it's been for a couple generations.
Not too bad. Yeah. All right. Well, you find that family fortune, let me know. So you and I met, I don't know, many years ago. You were working in this obscure thing called machine learning, AI, ML, which some people refer to, and moved into deep learning. And, frankly, not a lot of us had any experience. Now, you had actually been, trained and gone to school for this, and I think all the way up through your PhD. So why don't you just bring our listeners kind of up to speed in who you are, kind of your path, how you ended up here, and then where you're at now, because you actually, made a job transition, I guess about, I don't know, a year ago or less than a year ago.
Almost,
Yeah.
almost.
Why don't you kind of help fill in the dots there, and then you and I are going to get into all the good nerdy stuff that the listeners usually like to hear about.
Absolutely. Happy to. So let me try to I got to quickly through this. So I did my undergrad at Northwestern in social policy and also in economics. And then as soon as I went to DC, I worked in policy. I worked supporting the Obama administration. And so realized quickly I needed a lot more math. And so I had done a lot of math in undergrad and wanted to do more. And so when I did my PhD in public policy analysis, I did it at the RAND Corporation. So a profit organization who had 1,000 PhDs. And so they said, yeah, we can build a graduate program and let's just build it solely on tools, right? Let's look at every toolkit possibly to analyze how policy works. And so that's actually where my machine learning experience started. And that was when we were explicitly saying machine learning is not AI, right? We were making this big differentiation about it's, in some cases, 3 lines of code or not. And so I've been working in this field for a really long time. I was really actually, before I was working in the fundraising field, I was working with nonprofits and governments on the programmatic side. Right. So helping institutions understand once the money came in, how effective were you at the programs you were building with those philanthropic dollars. So that's really been my whole career. And then about 4 years ago, John Gleer brought me in to Grant's Gleer and Associates to GG&A to really beef up their statistics and their survey and benchmarking and analytics work. And so really fell in love with fundraising there. That evolution, right? GG&A was then acquired by Huron. And so it was there for a total of both places about 3 years. Really loved working with advancement shops across US, Canada, some UK and Australia shops, really helping them understand how to level up their analytics. And in some cases, building their own models, right? Folks wanted their own propensity models, their own affinity models. And then about 11 months ago, I moved over to Kindsight, who was a partner of ours, who I partnered with when we decided to move from our own DonorScape product to then iWave as a product. And then had the opportunity to jump into Kindsight, where I now lead our iWave team and our data science team and building some new products for the organization.
That's awesome. Yeah. And thanks for filling in all those dots. I think it's just a fascinating background. Now, the part that you completely lost me at was you enjoyed math. You wanted to do more math. And I just can't. That just doesn't even compute for me. So I did everything in undergrad and grad school to avoid math. I was like, if there's some other way or loophole I could take to avoid taking anything math oriented, I would do that. Now, I actually spent most of my time in economics, which has math, but I feel like there's a lot more BS room in economics. So it's all theoretical.
Are you macro or micro?
Yeah, more macro for sure, just because I don't like being held accountable. So, and Well, it's funny you talk about Rand too, because I did something with Rand not long ago at Harvard Law on essentially a war game simulation around this idea that China basically had achieved AGI, artificial general intelligence, and we needed to brief the White House. And what was the answer? And so, or how do we compete and all that. So it's a really interesting kind of thing. Rand does a lot of they do a lot of that work. I mean, they do that work for the White House continuously and trying to draw from different types of experience. And it was the economists in the room that drove me crazy the most, because they said, well, you have nothing to worry about because, no matter what happens in AI, the economy always grows at 2%. And, people like getting in their minivans and going to pick up their kids from soccer and eating ice cream after. So you don't really have anything to fear because that is going to remain constant, because it always has. People don't change, and politics don't change quickly. And I remember bringing up, like, well, I don't know, can many of you remember a few years ago in a thing called COVID, and the first 3 months of a year, everything changed politically, economically, societally. And they didn't really have a lot of explanation for that. Although, to their defense, if you look at things in a long enough horizon, things do tend to normalize, right? So it's like, well, yeah, in that moment, things change, but then it went back to kind of status quo. So yeah, love it that other people love math and want to get deep in that, because essentially AI is all math. And at a certain point, whether it's predictive or generative, we're talking either statistics and just probabilities of things happening. So it's great. From the first time, I remember the first time we talked, I was like, oh my gosh, I finally found someone that actually is kind of like not just talking about these things, but actually doing them. So kind of when you started entering the nonprofit workforce, maybe at the John Gleer work in building out models, in terms of technology a while ago, in terms of the accessibility and affordability of that technology, like how have you seen that happen going back? I don't know how many years ago was that to today. Maybe, well, let's talk about principles versus technology that you use to surface predictions. Like, how have you seen that progression change since you started to where it's at now?
Yeah, I would say speed is the biggest thing, right? We can iterate so much more quickly. We can come up with new ideas, test them out, build synthetic data, right? Run through the pace is so much different. But what I find that myself coming back to often, particularly with my data science team, is you have to understand the core basics. And that does go back to understanding the math, right? Understanding the statistical principles we're operating with, understanding the assumptions we're making. So you then understand why we're seeing these differences. So not to harp on, I feel like I'm dating myself, but you have to sort of start with the core, right? You have to understand the basic stats and then what it's doing to then tell you why. A few years ago, I would work with organizations who would say, well, I threw all this data at a model and it was amazing, and what it spit out here was this prediction. And I would look at it and I would say, sure, but you're predicting really on two variables you shouldn't predict on, and you don't actually understand how the model is working. And so you're making these this assumption that this tool will magically answer some question without really understanding the implications behind it. Where I see folks evolving now is that people understand a little bit more about bias. They understand a little bit more about, right, reinforcing bad stereotypes or bad data. And so that conversation has evolved a lot about ethical principles and the kinds of protections you need in place. And that at the end of the day, it really boils down to how good is your data, right? How good are you feeding these models? But then how well are you predicting going forward? So I think there's been an evolution in speed. There's certainly been an evolution in tools. There's been some translation that's been amazing across industries, talking about economists, right? Economists, we code in Stata, which is a proprietary language that really nobody else uses outside of economists. Now we're working with computer scientists, and we're working with data scientists, and we're working with physicists, and right, that kind of language translation, as folks have had kind of core, I operate in Python or I operate in some other tool. Now that all of those silos are broken down, because we can just use an LLM to translate that.
Yeah, the accessibility has definitely changed. I mean, when we started building machine learning models in like 2017, it was me with a pocketbook and really smart people around the country. So found someone in New York who's doing predictive AI in pharmaceutical work, predicting which doctors were most likely to be interested in a certain type of drug. Found a company in Silicon Valley working out of a basement, like the classic, like no windows kind of like group underneath the street working in this basement, and then hired a PhD on my team to do this because it was not accessible. I mean, it was just tremendous. I mean, I forget how many thousands of lines of code our first model was. but it was you really, unless you were deep into code and math. And in fact, our first model, we had a PhD statistician and a PhD computer scientist working together to really try to understand, can we predict generosity? What will it take? I mean, the first kind of barrier was like, can it be done in any way that's somewhat secure? And then second, how do we understand bias in terms of speed? And also what our ability to understand bias has changed a lot because models have been built on models that flag things that are overfitting and or look suspicious and whatever. And so how have you seen the progression? Because early on, I'd heard a lot of people say that these data garbage in, garbage out. And you just talked about data hygiene, garbage in, garbage out. So there was so much distrust and dislike of predictive AI. Conversely, all those people were using RFM scores, by the way, and it was like insane. But how has that changed now with like synthetic data and normalizing data? Do you feel like, is that real? Is it a myth? Like, is it still the truth of data, garbage in, garbage out? Or are models now better at, I don't know, filling in the blanks and starting to like use smaller data sets to actually make better predictions?
Yeah, it's a great question. I think you can iterate more quickly with synthetic data. I still think you have to look at bias at a whole. And that's less of a, like, do I have this particular data element and more, do I have somebody who understands the system, right? Do I understand something that's built in? Early days, I was working with actually a community college, threw every piece of data at a model. They said they were going to build a decision tree model and we're going to throw every piece of student data that we possibly have at this model. When I looked at the output results, I went, oh no, you threw in race and ethnicity and that ended up being one of the predictors that you ran with. And they didn't even see that in their own model, right? So there are easy things like that now LLMs can call out for you and you can point out, even if you don't understand now how it's working, right? There's some easy ways for you to flag, but there's also just some broad bias. The thing I see in advancement in particular is just that we don't have full data coverage. Right. So when we think about things like, I feel like the conversations they have around engagement data, right? When we have kind of biases in what engagement data is being brought in, right? If you're only seeing part of the picture and that's because of more systematic or process pieces, that's not because you don't have the data available. That's where you're seeing bias trickle in. And so where I've seen it in advancement shops is that sometimes creates a self-referential loop.
Right.
Where people say, look, we've built this and we've trusted and we've tested this and look at our model, parameters. But what they don't realize is effectively what you're doing is just saying the same major giver that I identified 3 years ago is the same person I have because they've given before and you miss out the fact that you have kind of built in your own bias without recognizing it.
So how do you, like, continuing on that thread? So, draw on some comparisons. When we started working in AIML, we kind of had this, actually, one of the consulting firms that came back and was like, look, you got a pretty good answer out of your first kind of run at this, but if you had more data, we could increase the accuracy. And so we set on this path of looking at, okay, let's combine first party data, so the data that we owned, and we were at a cancer hospital, with third party data, which is data that we bought. So I started doing that. We started seeing that, yes, we could increase the accuracy of the models by 15 to 20%, depending on, the data and which data and the cost benefit of which data you're going to use. But then, so it led us on this path of like, well, more data is better. And what we realized after that, well, more data might be interesting, but it doesn't all have the same value. How are you kind of thinking about this now? Because we also know at the same time, there's an environmental aspect. You use 1,000 data points to compute a score or a prediction. It takes a lot more compute than it would to take 25 data points to produce a prediction. So how are you kind of balancing that, like the cost benefit of it versus the efficacy of the value of the prediction? And then I don't know if you even think about the environmental aspect as you're doing this as well.
Yeah, absolutely. We think about it all. I think it starts with, what is your end goal, right? Do we need to be directionally accurate or do we need to be precise with the value? I think it starts with the business case from the beginning. I think there's sometimes an overexcitement about, I have to build this to 97% accuracy. And if it's not 97 and it's 90, somehow I'm missing out here, right? But if the conclusion is, am I directionally accurate because I'm going to send out this appeal to this person, right? The risk is low. The feedback you're going to get is going to be more valuable. And so I often start with the end goal in mind and work people back from what they need to do. The other thing that I often work with my team is I actually asked the reverse question. How little data can we use to answer this question?
Right.
In both, because it speeds up compute time, because it lowers data costs, because it lowers environmental risk, right? Are there times when we are over-engineering this and can we pull it back? And so the way that we often operate is, let's look at the sort of proliferation of the data. What can we possibly pull in? And then let's think about it systematically, right? From both angles. So when we think about like building econometric models, going back to economists, we often think that there's two approaches, right? You take the end variable you're looking at and you take a couple of things that you think are predictive and you start there and then you iteratively build on top of them to add more data and see if that's valuable. That's one method, right? The traditional method. The other traditional method is let's throw everything at it and then slowly remove variables and see what has an impact. Those are two philosophical arguments, right, of how you approach this. The way that I think in an AI stage is the natural inclination is to go with the latter. Just throw everything at it and let's see what happens. We can do that to start as you're building models, but then you should naturally do that process of pulling back and do you really need all these things?
Yeah, we found in doing this for a while, again, it was very interesting to use all the data, but I mean, statistically, a feature, which is for those listening, it's a variable essentially, that no feature is essentially weighted the same. So some have higher prediction value than others. So things like age and ethnicity might have high prediction value, but are unbiased or are biased to put in there. So you want to remove those. And then you have other things that like event attendance or frequency of giving or number of days since last gift that end up showing up over and over again into like, say, what we would classify as like the things that were most predictive. So out of 1,000 data points, you might only have 25 to 50 that actually are producing 90% of the prediction. And so therefore, why are you computing, you can then prune those other features and actually then, save yourself a lot of compute power and a lot of heartache. When you're talking about this though, going from an economist perspective, when you were in the private sector to moving into the nonprofit sector, I think one of the differences is transparency and trust, because nonprofits don't exchange services or products. They exchange trust for money. How do you think about that and transparency or explainability as you're doing this in very real terms, like for the nonprofit sector? Does it look different in terms of either what the obligation is or how your example of finding that, people would use things that would be inherently biased? So how do you think about that lens from a practical sense?
Yeah, I think it's hugely different in the nonprofit sector than, let's say, like the government sector. My first big project supporting the Obama White House was to prove to the Senate at the time that we didn't have duplicative STEM programs, right? So every federal agency has a STEM program. How do we prove that mathematically? We ended up proving that mathematically from a algorithm that a graduate student had created. And we had in R, because it's an open source language, that they had built essentially a couple of months ago. So total black box, total unproven, right? Like we understood the math, but like nobody else really did. But the appetite there was great. I like the answer and I could explain it to a certain degree. If we did that on the nonprofit side, everyone would essentially say, I don't believe that, right? You have to show me what the variables are, how it worked, walk me through 5 examples of a prospect I know, right? And so I think the appetite's really different and the trust piece is really different on the nonprofit side. And I love that actually about the industry, because people are much more attuned to, well, tell me what data that is and how it worked. The part that I love about Kindsight, and part of the reason I joined, was just their history of transparency. They've been so open about what their models are, what the underlying data is, how those calculations are done, so that we can talk to clients and to prospect researchers and gift officers. Here's how we got to this math. Here's how we prioritized this prospect over that prospect, this engagement over that engagement. And actually, I presented at AFPICon a few months ago, kind of core questions you should ask of every predictive AI company, because they should be able to answer those, to be able to tell you what's the data trained on, what is the purpose of it, how is it being updated, right? How did you control for bias? Because I think that is so important, but it's ingrained into the nonprofit culture in a way that it's not ingrained in say, government or in private industry.
Yeah, no, I mean, I'll double down on that. The thing about Kindsight has been, even Shiri and Koshi, who's there and is a, really good friend of mine. We worked when I was at Donor Search. I mean, we were literally direct competitors. I mean, like there's really only a few data providers in the nonprofit space. So competed kind of head to head. And even at the time, when he and I started kind of thinking about the sector together and some of the unsolved kind of research studies, like Who's Asked the Donors, where like Kindsight actually was just always, very supportive of him being able to do things, even though it may be confusing for the end user of like, wait, I thought he worked there, but he's working with this other guy. And so it's been, really great. And it's just amazing, that they take that responsibility seriously around not just building models that are, profitable for-profit company, but that are representative of the needs of the sector itself to ensure that there's that inherent layer of trust in there. Now, the one thing that as we move into this, because in a lot of ways, I think AI ML, so AI machine learning, is actually much easier and more straightforward. Now, for people who aren't aware of, the terms and how this works, it seems like it's all really difficult and sciencey. But in terms of explainability and transparency, I feel like so much easier than generative AI. And so, do you agree with that? And generative AI is this like mosh pit of like stuff, and no one, even Sam Altman, knows how it comes up with its things. So does generative AI end up consuming AI/ML? And if it does, will it be able to do it in a way that increases transparency? Or is there always going to be a need for true like data science, machine learning as a separate discipline from generative? Because I think a lot of people are confused. They're like, well, I can put a spreadsheet in here and it can give me a prediction, and may or may not actually know if it's accurate or how to prove that it's accurate.
I think there are a couple of threads there. I think one is, I don't know how much folks have tested out Gen AI and doing math. It's pretty bad. It's pretty bad. No matter what model you're using, no matter kind of the instructions you're giving it, the ability for it to make mistakes is surprisingly high when it comes to math. So I would say in general, when folks have asked, like, should I throw this spreadsheet at it and have it create this? I have more trepidation because I think there are easier ways to do the same work in more reliable ways. So I would say, I think today, in today's technology, and this could change in 3 weeks, right? We see how fast this is evolving. But right now I see, Gen AI is really not being that kind of math source. So I think there's so much to rely on for machine learning and machine learning methods. The example I think back to, and I had actually a mathematician teach me this in grad school, is going back to your China example was optimization. So the idea of how do we find the right set of assets. And so we had this concept called ant colony optimization, right? It's a mathematical technique that essentially mimics what ants do, which is ants walk along a path, and the ants who find food then have released a pheromone that show here's where that path walks. And so you create essentially a mathematical model that does the same thing. We shoot off a lot of ideas. We see the ones that hit the end goal and come back to it, and that reinforces the idea of this is the right pathway to go. So really sort of simple concept from a comparison standpoint, but also from a code standpoint, that's actually 7-8 lines of code at an elegant rate. And so I think that still has its huge value, a huge kind of opportunity there, and also addresses, frankly, a lot of the environmental concerns we run into with these large language models that run for, days or hours on time and come back with an answer that may or may not make sense. I still think there's huge value in machine learning and that kind of richer history of skills and kind of technology. Even though it's, quote, older, I still think it has a lot of utility and value. But I do see as we move towards more and more agentic solutions, you're combining those traditional machine learning ML techniques with then generative AI.
Yeah, so we'll continue on that thread because you're already going where I was thinking. So, and I think of AI right now, even though there's many other classes of AI, but kind of a three-legged stool. In just to completely generalize, but predictive AI is kind of this first kind of proven leg of the stool. Not new at all. Going back to literally 1955, but not really accessible and affordable until maybe 10, 15 years ago. And then generative AI, which doesn't necessarily, it's not good at predicting things, but it's good at taking predictions and creating something new from them. And then to your point, agentic. So I've been thinking more and more about this because one of the things that we didn't really expect early on in machine learning was that we would get better results by using multiple models that were essentially competing against each other and averaging out. And so Google started doing this thing where it's like, we built one model and it was just one model. And it was like, okay, it could produce a score, but we had no idea if it was, we kind of realized that there's no one model that's best for any one data set. And so we started actually then having many models compete against each other, and then those compete against each other, and then we take kind of the best or the average of the best. I'm wondering, to your point, like this agentic piece, agents can spin up specific things for specific tasks. And so it spins up a AI ML kind of competitive race over here. And then it's at the same time spinning up its generative thing. So do you kind of see that all kind of converging here? And if so, like how long is your prediction for that to be somewhat accessible for nonprofits?
Yeah, so we're seeing that in the science and R&D space already, right? Where they're essentially saying, well, it would have taken us months or years or entire research studies to test out 3 or 4 different types of models for something. We can now build an agent, right? Give it the same data set and say, go run and tune all of these. And so I think we're seeing it in science space happen and actually help spin up faster innovation on that side. I think for nonprofits, we're not that far away. I think the bigger hurdle, frankly, will be, do we have good data to feed them, right? I think that's always inevitable in it. And do we have folks who really understand how to leverage those, right? I think it's those 2 spots is the data and the people. But from a technology standpoint, there's just huge leaps and bounds to being able to do things that were literally 3-year research studies that we can run in a day and a half.
Yeah. I was in DC this week and someone brought up this kind of an interesting point I hadn't really considered before, but it was this panel I was doing and someone's like, well, is it easier or better for a nonprofit to just do this themselves? They just hire the person and they do this internally because the tools are accessible and they're $20 a month and whatever, or do you hire it out? And someone actually jumped in and said, the issue with this of doing it yourself is that you find the subject matter expert who does this thing. They have a lot of inherited knowledge in the organization. And then guess what? They leave. And a lot of this is actually not all that transferable to a lot of it is like deep understanding of what you're doing and that code that you're managing to do this stuff at high, a lot of lessons learned and a lot of incremental progress along the way. And therefore, most likely better to actually outsource it and have someone that is actually accountable to manage and respond. So I think while people say I think it's actually completely misnomer that SaaS is dead, that these recurring services that are doing these things people are just going to do this themselves. I think there's a tremendous amount of risk for organizations that are just going to do this themselves for that very reason. Also, you only have the understanding of what one organization does if you're doing it internally versus outside consultant or service that like Kindsight that actually does this with thousands of organizations and can actually take those learnings and apply them. So, that's my own kind of bias to that. And, people say that CRMs are dead. And I actually believe that CRMs look very different in the future, but they're actually, and how you interact with them is very different, but they're absolutely going to still be needed in the future.
Yeah. I think democratization of tools is a great thing always, right? I think that is giving people tools at their fingertips and being able to customize for their exact use cases is great. But I would, double down on your points about bias, right? If you're looking at one organization's data, you're looking at one organization's data, right? And you need that kind of broader perspective to understand what we're looking at. But I also agree with you that I think data at its core, right? The CRM is at a core, right? Is the unit of where we have trust around the central data. I still think that is incredibly valuable because everything you build on top of that matters. Right. And so I think I love people who are experimenting. I talk to a lot of clients who will show me, hey, I built this agent in Microsoft Copilot because there's an agent builder, right? And it's made it simple and easy to run things. And so it helps clarify, small workflow changes, right? Things like I'm trying to customize a grantee letter or I'm trying to write an impact report. How can I do that faster? I think there's some great experimentation on the edges, but I think for core functionality, right? Things that are big decisions, you still need to have folks who understand all the context, can look at all of the data and not just your own individual institution, and who can help you think about workflows. I think the piece that I've found, and I don't know if you've experienced this with clients too, is when you show them how AI, if folks are using, CoWork on Anthropic, it can change all of your files and you may not have traceability into all of those things and you may not have wanted all of those. That to me has seemed like the point where people finally go, oh, wait, okay, maybe I should not release this to everybody in an organization because there's so much trickle-on effects that can happen in an unintended way.
Yeah, absolutely. So let's talk a little bit about the future. We don't have tons of time, but what are the things that you're either working on or that you will be working on or want to work on that get you excited about this? I think we've seen the progression of what's possible increase exponentially. So we went from this kind of nascent, like everything just grew in this incremental way with like small percentage increases. And now we have this like not even hockey stick, but just literally like the scale of AI over any longitudinal period goes from like straight across, then straight up, which then affords us the ability to think and dream a bit differently about what's possible. Is there anything that you are predicting, even if you're not working on it already, that the sector, the nonprofit sector, will benefit from as like the pace of technology continues to increase that way?
Yeah, I will say, I think the industry is embracing experimentation in a way that I don't think we've had in the past. And that's the part I think personally, I don't know if it's because I'm a researcher at a core, a data scientist at a core, but that part of willingness to jump in and say, let's try this, let's see what happens, let's make adjustments, let's get creative. I think that appetite for experimentation at small and big levels is growing. And that's the part that I find most exciting because we end up in partnership, right? So many of our clients, we are partnering together to think about how we build together and what they're willing to do. And that's the part that I find most exciting about this time is kind of going hand in hand and saying, let's see what happens and where we go. And let's put, of course, all the appropriate guardrails and protections in, but people are more willing to come to the table and try something new.
Yeah, that's great. I mean, I'm glad you're experiencing that. I speak a lot on curiosity and imagination, and it's more challenging than it sounds for people because if you've only had technology that operated in a static kind of predictable way, then there's no need for imagination. You just need to learn to have proficiency. But when you have tools that are capable of kind of dreaming alongside you and coming up with new ways of doing things, to find out that that scarcity mindset or that, static mindset doesn't serve you well. So I'm glad you're seeing that. I've seen more and more, even of our customers who have been just a little bit AI curious, realizing that like all software is built for averages. There's no, like, it's been impossible to build a software solution specific to one organization at scale. Very, very large organizations do that. But the average, you have to build a software platform that works for the most number of people. But AI allows you to then take that as that core piece and then modify it to, treat your organization as the special snowflake that it is. And so I think that's a pretty exciting part of the future, but it will require us to continue to dream and experiment and be willing to fail and try new things and different approaches. And then also realize that if it's not possible today, it doesn't mean that it's never possible, that it might be a next week or a year from now. I mean, based on how fast things are moving.
Yeah, absolutely. I mean, I will say, I was at Huron, we were a Copilot shop, right? And we started at Copilot when functionality was really limited. We tested the bounds of it and we went, okay, let's wait until it gets better. And then 3 months later, that we knew we couldn't, that we had tried and failed on. So the pace of innovation, I think, is also part of the excitement is, when Fable came out, that was all of our teams going, no, I'm curious. Let's just try it, right? And that kind of like jump in and seeing what we can do that we knew we couldn't do, the prior week.
Yeah, and Fable's insane. For those that are like close to this and they know the limits of what their tool can do on any given day, and then the next day, there's something that completely opens the aperture. And, it's just absolutely wild to see. You're like, oh my gosh. And then I find myself in a constant state of reimagination because you could only imagine up to a certain point because the capabilities, and then something new comes and you're like, this just opens the possibilities wide open. So yeah, that's awesome. So just as we end this, I'm always curious what people, and people ask me a lot, I'm sure they ask you a lot, what's your favorite tool that you use? If you could only have one AI tool ever, like just one, you're not allowed any other tools, what would that tool be? And then why?
Yeah, that's a great question that I hadn't thought about the answer to.
It's a completely unfair question for any AI person. Torture.
I'm going to go for the low-hanging fruit because it's a piece I'm not good at. So the parts that I love about AI for speed are the parts that I generally spend time on but don't want to spend time on. So Claude Design for me has been the piece in the last couple of months has just purely accelerated my ability to present and to communicate and to come up with new ideas and to ideate and to share a lot more internally and externally. So that is not at all core to the data science work that we're doing or the whole pieces, but I find as a part of, I'm not a natural marketer and I think somewhat good at design, but don't like obsessing over pixels for that purpose. I love assessing pixels for SaaS products. That part has been selfishly like so much of a faster gain without having to put out a lot of energy.
Well, fortunately for you, Claude Design is now part of Claude, so you don't have to pick between the two. I'll give you both. So you can have Claude in all of it. So I think you're in pretty good shape having all of the Claude suite with Claude Design. People that don't know about Claude Design, it is pretty ridiculous because to your point, like I used to think about how long, it's like, oh, I've got to do a new PowerPoint for this thing. And gosh, I mean, like you'd spend an entire day, just like, should this color be here? And should I put a circle over here to make it look better? And then frankly, it's like the lowest common denominator. But now it's like, I was literally had my laptop open. I was at a conference, had this breakfast meeting. I thought it was interesting and I was going to be presenting 15 minutes later. I walked from breakfast to the conference center, Claude Design open, and I had to keep my laptop open so I could stay connected to Wi-Fi. By the time I walked from breakfast to the conference center, I had a full-blown PowerPoint built that I actually plugged in and actually showed. Like, and it was actually able. I was just going to use either notes or just go off the top of my head, but I'm like, this is so much better. So, I mean, to your point, like a data scientist becomes presenter or a marketer in from that sense. And I think that's where, and marketers become product people and product people become software engineers. So everyone has these tools to like really level up what the capabilities of their jobs are.
And I think communicating, right? I think because I'm a researcher, it's easier for me to write a 5-page memo than it is to write a 1-pager flyer.
Yeah.
And now I don't have to bother with the kind of like thought process of how do I boil this down. I can just use an LLM to help me figure out and experiment. I think that's also just a great thing for all folks, right? Product marketing, others, is that you can throw it and say, give me 2 different versions and help spark some additional creativity.
Yeah, well, it's such a pleasure to connect with you and to hear more about your work. I'm excited about the future of this area, this part of the house, just because going back to, we mentioned RFM for just a second, recency, frequency, monetary, and I was doing some research last week, and RFM scores were developed in 1930 by catalog producers, right? They wanted to decide who to send a catalog to, the people that were most likely to buy something, because catalogs were expensive. And they were started not in an Excel file or any type of digital file. They were literally cards, index cards on a table that they would restack to determine who should get that. And to see that our sector for pretty much since that time has been using that as a way of classifying good versus bad donors. And I don't know, do you have a prediction on how many nonprofits are still using RFM scores if you had?
Oh, I would say north of 90% of them are still
a lot. A tool that was developed in 1930 on index cards, moving into an era where every person can be an N of one, every person could be essentially understood at an individual level, is really exciting. And it can't happen without this side of AI that I think a lot of people, most people would assume, oh, you talk about AI and you're talking about ChatGPT or Copilot. But I would consider this is like the engine that actually makes the car go. Otherwise, or maybe the steering wheel. Because the car might go and it's going to crash into a wall and not be very helpful. But yeah, I appreciate you diving into this work and helping steer the industry in a way that brings value, that brings clarity, that does it in a way that is responsible and transparent as well. So, I mean, we need more people like you that are, pushing the envelope on this type of work.
Yeah, appreciate it. And thanks for voicing these kinds of conversations and offering folks perspectives here. I think this industry is changing so fast. And so it's great that you're helping kind of surface all of the changes as they come.
Well, it's definitely it's an incredible group of people that really care about their organizations, but they care about humanity as a whole. So, well, stay tuned for another episode of the Fundraising AI podcast, and we will see you again soon. Thanks so much.